Good morning, my dear students. I am Mohammad Bahaddin, working as an assistant professor in ISL Engineering College, which is approved by ASCT, affiliated to this small university in Hyderabad. So today in the sessions we are going to learn the second problems on the helical gear. Okay. A motor shaft running at 1440 rpm to transmit the power. Here, a motor shaft running at a speed of 1440 rpm to transmit the power is 15 kilowatt to a low speed shaft with a speed reduction through the helical gear having the helix angle. Here angle is given here, alpha is 25 degree. The transmission ratio is I value is given here 3:1. The teeth are 20 degree full depth involute systems and the pinion having the 25 teeth. The number of teeth on a pinion, how much is given here? Z1 is given here, 25 teeth is given here. As well as the pinion is made of cast steels C20 treated 0.2% of carbon, and gear is made of cast steel is C20 untreated 0.2% of Brinell hardness number 250 for the pinion and 180 for the gear. The starting torque is given here. Starting torque is always 10% greater than the rated torque. The specific detail for the drive for the safe and continuous operation. Also check the dynamic and wear load we need to find out in this problem, as well as the modulus of elasticity of the materials is given here 2.1 into 10 power of 5 Newton per mm square is given over here. Let us see over here a motor shaft. First of all, you have to write down the given data, in which you have to represent here a motor shaft running at a speed of 1440 rpm. So speed of the pinion is given as here. So here do one thing here, this is the 1440, make as small changes over here, 1400 1400 rpm. If you divide by 60, then you will get 24 rps. Okay, and the transmit the power is how much is there? 15 kilowatt. Power is given here, 15 kilowatt is given, 15 into 10 power 3 watt is given over here. And power to the low speed shaft with a speed reduction through helical gear having helix angle. Here angle is given here, helix angle beta is given as 25 degree and the pressure angle is given here 20 degree. Clear? So here in this case helix angle is given at 25 degree and this pressure angle is given as here 20 degree. Clear? And the number of the teeth on the pinion is given here 25. Okay, then we can easily find out the number of the teeth on the gear. We can easily find out I is equal to Z2 by Z1. I how much is there? I is given as 3. Z2 we need to find out the number of the teeth of the gear. Z1 is given here, the number of the teeth on the pinion is how much is given? 25. The number of the teeth on the pinion is how much we got here? 25. Actually what is our intention is that we need to find out how many teeth are there on the gear, we need to find out. So for that reason just you need to multiply 3 into 25, then you will get this value of Z2 is how much? Z2 is 75. So this means that the number of the teeth on the gear is 75, the number of the teeth on the pinion is 25. The number of teeth on the gear is how much is there? 75. The number of the teeth on the pinion is how much is there? 25. As well as after that our intention is there, we need to find out the speed of the gear, we need to find out over here. So I is equal to n1 by n2. So I is 3 is given here, n1 is how much is given here, 1400 is given, okay, by n2. So in the problem is given the mistake over here, 1440 is given here. So please do the correction over here. Instead of 1440, just you have to represent 1400 rpm. So okay, 1400 by n2. After that, if you are calculate over here n2 as it is, cross multiply over here, n2 is equal to 1400 by 3, then you will get the value of n2 is how much is there, 480 rpm. So if you divide minute to second, just you need to divide it by 60, 480 by 60, then you will get rps, okay, here this is rps, okay dear. rps. After that, step number 1. So in the step number 1, refer the table number 12.7, page number 234 for the given Brenner-Hades number. So the static strength for the pinion is given as 193.2 because pinion is made of the 0.2% of cast steel treated. So for that reason you have to go for table number 12.7, page number 234, then you will get the value of sigma d1 as well as sigma d2. Sigma d2 nothing but then the static stress of the gear, because the static stress of the gear, it's made of the untreated the cast steel. So the Brenner-Hades is how much is there, 180 is given over here. So sigma d1 value is 193.2 megapascal, sigma d2 value is how much is there, 138.3 megapascal. After that you need to find out the equivalent number of teeth for the pinion as well as for the gear, we need to find out. So equivalent number of the teeth on a pinion, we have to use the formula is that E1 equal to Z1 by cos cube beta. Z1 nothing but how much is that, 25 by cos cube into 25. If you divide the whole the value, then you will get the equivalent number of the teeth on a pinion is how much is there, 33.58. So it should be approximately equal to the 34. After that, equivalent number of the teeth on a gear, ZE2, we have to use the same formula, is it right? So you have to refer the page number 211 and equation is 12.22a. So instead of Z1 you have to use the Z2 by cos cube beta as it is. So the number of the teeth on a gear is 75 by cos cube 25. Okay, if you divide the whole the value, then you will get the answer is how much is there, 100.75 should be equal to 101, we can say that. So the equivalent number of the teeth on a gear is how much is there, 101. The equivalent number of teeth on a pinion how much is there, 34. After that, what we need to find out, we need to find out the form factor for the pinion as well as the form factor for the gear, we need to find out. If you want to find out the form factor, we have the formula y1 equal to pi y1. The small y1 is Levy's equations. So pi, so y1 we have the formula is 0.154 minus 0.912 by ZE1. 0.154 as it is minus 0.912 by ZE1 value how much is the 35. If you are divide the whole the value as well as if you multiply with 3.142, then you will get the form factor value for the pinion is 0.3995. As well as what we need to find out, we need to find out the form factor for the gear, we need to find out. If you want to find out the form factor for the gear, we have to use the same formula. Instead of y1 we have to use the y2 only. Pi as it is here 0.154 minus 0.912 as it is. Instead of ZE1 we have to use the ZE2, that's it. After that, so 0.154 as it is 0.912 by ZE2 how much is that, the number of the teeth on a gear is how much is there, 101. If you divide the whole the value, then you will get the y2 value is how much is there, 0.4554. Clear? After that, first of all you need to draw these tabular column in which you have to write down the parameter in which we have to using the two gears, pinions, another one is a gear. The number of the teeth on the pinions how much is there, 25. The number of the teeth on the gears how much is there, 75. The allowable static stress of the pinion is how much is there, 193.2. we are found it from the table. the allowable static stress for the gear is how much is there? 138.3 megapascal, and the form factor for the pinion is how much is there? 0.3995, and the form factor for the gear is how much is there? 0.4554. Clear? And then the strength factor, if you want to find out, just you need to multiply the allowable stress into form factor. 193.2 into 0.3995, then you will get the answer is 77.183. If you multiply 138.3 into 0.4554, then you will get the answer for the strength factor is 62.981. So here, which one is the stronger one? Because pinion is the stronger one, because the static strength factor should be greater than the gear. So how much is there? Static strength factor of the pinion is 77.183. So this means that it's the static strength of the pinion is greater than the static strength of the gear. So for that reason, we need to design on the gear, because the gear is the weaker section. So here in this case, the gear is a weaker section. For that reason, we need to design on the gear. And step number 4, in which what we need to find out? We need to find out the mean torque. We need to find out. Okay, so we have to use the power formula P equal to 2 pi n2 T mean by 60 into 1000 into CS. Power is already given 15 into 10 power 3 watt. 2 pi into the speed of the gear is how much is there? 480 into T minimum, how much is there? As it is by 60 into 1000. If you just multiply over here, then you will get the mean torque values. How much is there? 298,415.58 Newton mm. After getting the mean torque value, just you have to represent T maximum value. So here the T maximum should be 110%. If you divide the 110 by 100, then you will get 1.10 into T minimum value. What is the formula? T max 1.10 into T minimum. 1.10 as it is, the T minimum value is that much only, 298415.518. Substitute over here. Just after that you need to multiply with 1.10, then you will get the T maximum value is 328257.0698. After getting the value of T maximum, we need to find out the normal module. We need to find out Mn is equal to 2 into moment of torque into Cw into cos beta by sigma d2 into Cv into k into y2 into z2. Minimum phase width, we have the formula B is equal to 1.15 pi into Mn by sin beta. You have to refer from the page number 213, and equation is 12.23 from the design handbook by Mahadevan. So first of all, K, the K formula is there. K is equal to B by module. So you have to refer from the page number 214, equation is 12.24b. So after that you need to substitute over here. So K, B value, what is the formula is there? 1.15 pi into Mn by sin beta by Mn as it is over here. This Mn and this Mn will cancel over here. 1.15 pi by sin beta value, how much is there? 25. If you divide the whole the value, then you will get the value of K is 8.55. After that you need to go for table number 12.24, well laminated gear purpose. So Cw we have to consider over here is 1.15 continuous lubrications we are using in between the two gear. We have the formula Mn equal to 2 into moment of torque into Cw into cos beta by sigma d2 into Cv into k into y2 into z2. So if it is moved toward here, it's make as power is 3 into Cv, 2 into moment of torque into Cw into cos beta by static strength for the gear into, we can say as the load factor into form factor into Z2, nothing but what we can say the number of the teeth on the gear, we can say that. If you substitute the value over here, then you will get the answer is 16.946. Okay, after that, okay, we need to find out the pitch line velocity. We need to find out. We have the formula is V is equal to pi d1 n1 by 1000. So d1 we have the formula is module into number of the teeth on a pinion. Okay, Mn into z1, Mn into z1 into n1 by 1000. Mn, how much is there? So Mn into z1, nothing but the number of the teeth on a pinion is 25, and the speed of the pinion is 24 by 1000. If you divide the whole the value, then you will get the 1.8849, because Mn is an unknown value. Clear? After that we need to find out the velocity factor value. We have the because velocity is more than 20 here, if it is lies in between 50 to 10 meter per second, because let us see then we have to use this formula. CV is equal to 6.1 by 6.1 plus V. So 6.1 plus 6.1 plus velocity is 1.8849. so after that, because it is difficult to find out the value, because here the two values unknown, CV is unknown and Mn is unknown, we have to keep as it is only. After that, this CV value we need to substitute in the above equation. Over here in this above equation, Mn cube into CV equal to 16.946, in which we have to substitute this value of CV in the equation number A. Mn cube into CV equal to 16.946. Mn cube as it is, CV value is how much is there? 6.1 by 6.1 plus 1.8849 Mn equal to 16.946. So Mn cube as it is. So after that, here we are taking over here 6.1 is common over here. Otherwise you can divide over here 16.946 divided by 6.1. So remaining here is 1 by 6.1 plus 1.8849 Mn. Clear? After that you want to multiply Mn cube by 6.1 plus 1.8849 Mn equal to 2.7780. Just need to multiply this one, then you will get the value is Mn cube equal to, if you multiply 2.7780 into 6.1, then you will get the answer is 16.9458 plus 2.7780 into 1.8849, then you will get the value is 5.2362522 Mn. Okay, if it is moved toward this side, then after that we have to form it's a form of ax cube plus bx square plus cx plus d equal to 0. After that we can easily find out with the help of calc, then you will get the value of module is how much is there? 3.236. So 3.236 should be approximately equal to we can say as the module we have to consider as the 4 mm. After getting the value of module, we have to substitute in the phase width formula. So K is equal to B by Mn. So B as it is over here, K into Mn. So K is, we can say as the load factor value is 8.55 into Mn, nothing but module is how much is there 4. If you multiply over here, then you will get the phase width is 34.2 mm of the gear. After that we need to find out the center distance between the two shafts. We need to find out. We have to use the formula A formula we have to use from the page number 211, and equation is 12.20 you have to consider. And the number of the teeth on the pinion is 25, the number of the teeth on the gear is 75 by 2 into Mn is nothing but module 4 by cos beta nothing but cos 25. If you divide the whole the value, then you will get the center distance between the two shafts is 220.6 mm. So after that we need to find out the tangential tooth load we need to find out. So for that reason you have to use this formula, FT formula, from the equation number 214 and page number is 12.24a. Clear? So always you need to remember over here the velocity formula is 1.8849 Mn. So 1.884 already we solved in the above, is it right? So 1.8849 module formula is how much is there 4. If you multiply this one, then you will get the linear velocity is how much? 7.5396 meter per second. After that you need to put in the velocity factor formula. CV is equal to 6.1 by 6.1 plus 7.5396. 6.1 by 6.1 plus V. Okay, so if you divide the value, then you will get the velocity factor value is 0.447. Clear? Then after that CW value you have to consider from the 1.5 from the table number 12.21 from the page number 241. After that we need to substitute over here, then you will get the tangential load is how much is there? 3348.96 Newton. After getting the tangential to the load, we need to find out the power developed due to the tangential load we need to find out. So always you need to remember whatever the power is given in the problem, it should be greater than our answer, then only the design is safe, otherwise our design is not safe. Clear? The power developed due to the tangential load, we have the formula PQ is equal to tangential force into linear velocity by 1000 into CS. So FT value is how much is there? 3348.96 into V, how much is there? V value already we got it as a 7.536. 7.536 by 1000 into CS value always you need to consider as the 1. If you divide the whole the value, then you will get the power developed due to the tangential load is how much is there, 25.23 kilowatt. So our answer should be greater than the power, whatever the power is given in the problem. So in the problem is power is given as a 15 kilowatts, but our answer is getting as a 25.323 kilowatt. So that's what we can say that our design is safe. Okay, after that we need to find out the diameter of the pinion. We need to find out. For that reason we have to use the pinion diameter formula. Mn is equal to d by z1 into cos beta. You have to refer from the page number 211. From the equation is 12.19 c. So modulus formula is for d1 as it is. The number of the teeth on the gear is 25 into cos beta nothing but 25. Just you need to multiply 4 into 25 equal to d1 into cos 25. If you divide over here 4 into 25 by cos 25 equal to d1. d1 how much you got it here? 110.34 mm. So after that we need to find out the value of d2. We need to find out I is equal to d2 by d1. So I ratio is given here 3:1, or we can say as 3. We can consider over here 3 equal to d2 nothing but the diameter of the gear. Keep as it is because it's an unknown value. We need to find out the diameter of the gear. And d1 nothing but 110.34. Just you need to multiply over here d2 equal to 3 into 110.34. Then you will get the gear diameter is 331.02 mm. After that our intention is that we need to find out the dynamic load, because he's asking you need to solve the dynamic load factor value. If you want to find out the dynamic load, then you have to refer this equation from the page number 214. From the equation number is 12.26a. Okay, and K3 is how much is there? 20.67. So tangential loads we have the formula is 2 into moment of torque by d2. Clear? So this FT tangential force we have to refer from the page number 206 and 18.28a, because our gear is weaker than the pinion. So that's what we are. I am taking this value 2 into moment of torque value how much is the 328,257.0698 by diameter of the gear is how much is the 331.02. If you divide the value, then you will get the tangential force is how much is the 1983.306 Newton. So after that our intention is there we need to find out the dynamic factor value. If you want to find out the dynamic factor value, in which we have to refer the table number 12.13 page number 237. For the normal module we have to consider here 4 mm. Error in the actions we are taking here 0.127 mm for class 3rd precision gear. So for the dynamic factor we have the formula C is equal to E by K1 in the bracket 1 by E1. E1 nothing but the modulus of elasticity of the pinion, and the E2 nothing but the modulus of elasticity of the gear, and E nothing but we can say as the error. Okay, and K nothing but the load factor. So you have to refer from the page number 12.12 page number 207. So over here K1 we are taking here, and for the 20 degree full depth invalid purpose we are taking over here. So here error is how much is the 0.0127, and the K1 is the 9 value is given. The modulus of elasticity of the pinion is given here 2.1 into 10 power 5. The same as it is for the modulus of elasticity for a gear. If you divide the value, then you will get the dynamic factor value. C is how much is there? 148.16 Newton per mm square. After getting the value, then you need to substitute in the above equation FD value. You need to substitute over here. In this equation, you need to substitute over here. If you substitute, then you will get the dynamic load factor value. Okay. So dynamic factor value, then you will get the answer is 6432.256 Newton. After getting the value, dynamic factor value, we need to find out the power, how much power it developed due to the dynamic load. So we have to use the formula P kilowatt is equal to dynamic force into V by 1000 into CS. So dynamic factor value is how much we got here, 6432.256 into V value is how much is the linear velocity is 7.5396 by 1000 into CS values always should be assumed as 1. So the power developed due to dynamic loads, we are getting the answer is 48.49 kilowatts. So it should be greater than the 15 kilowatts. So for that reason we can say that our design is safe. Okay. Okay, after that we need to find out the VL load check we need to find out, or we can say that VL load we need to find out. We have the formula to find out the VL load. FW is equal to D1 BQ into K by cos square beta. It should be greater than the dynamic force. So we have the, first of all we need to find out the value of Q. Q is equal to 2Z2 by Z1 plus Z2. Z2 nothing but the diameter, so the number of the teeth on a gear. Z1 nothing but the number of the teeth on a pinion, the number of the teeth on a gear. So 2 as it is, the number of the teeth on a gear is 75 by the number of the teeth on a pinion is 25 plus the number of the teeth on a gear is 75. If you divide the value, then you will get the answer is Q is how much is there, 1.5. Clear? Then D1 value is how much is there, 110.34 into B is face width value 34.21, Q value is 1.5 into K value is how much is there, K value you can easily find out 0.632 by cos square beta value is how much is there, 25 mm. After that, if you divide the whole the value with the help of calculus, then you will get the value of VL load is 4363.78 Newton. It should be greater than the dynamic force. So for that reason we can say that our design is safe. After that we need to find out the power developed due to the wear. We need to find out P kilowatt is equal to FW into V into 1000 into CS. Okay, FW how much we got here, 4363.78 into the linear velocity is how much we got here, 7.5396 by 1000 into CS values always should be equal to the 1, you know very well. So if you divide the whole the value, then you will get the power developed due to the wears is should be how much is there, 32.90 kilowatt. So this means that it should be greater than the, in the problem P how much is given, 15 kilowatt. It should be greater than the 15 kilowatt. So for that reason we can say that our design is safe. Clear? I hope so no one is having the confusion regarding the up to over here. If you have the doubt regarding this problem, please write down in the comment box, and please don't forget to subscribe my channel dear. Thank you.